In this numerical question, this equation is given that shows the electrolysis of sodium chloride to produce hydrogen gas, sodium hydroxide, and chlorine. So industrially, chlorine and sodium hydroxide, both of them are produced by electrolysis of sodium chloride. But for hydrogen, there are several other ways as well. Anyway, our focus is to calculate volume of chlorine gas produced at STP. You know, STP means standard temperature and pressure. And at standard temperature and pressure, 1 mole of any gas occupies 22.4 decimeter cube. And how much amount is given here? 58.5 gram of NaCl. Total number of molecules of chlorine, you are to calculate the total number of molecules produced. Means how many chlorine molecules would be there in this volume of the chlorine gas. So in all these stoichiometric calculation, you need atomic masses. So the atomic mass of sodium is 23. It is given in the paper. Atomic mass of chlorine is 35.5. So remember that these all are given in the question paper. Atomic masses are given there. So you need here the molecular mass of chlorine and the number of moles of sodium chloride. So always the first step in such solutions is to calculate the molar masses and the number of moles so of the given reactants. So here we need the molar mass of NaCl, molar mass of NaCl. How can you calculate it? You know, there is one chlorine, one sodium, so it would remain 23. 1 multiplied by 23 is 23, plus 1 multiplied by 35.5, so it would remain 35.5. So on summation, you will get 58.5. So this is the molar mass, and its unit is gram per mole. And you know here, 58.5 gram of NaCl is given. So it is same, so it means it would be 1 mole, but we have to show the calculation. So the number of moles of NaCl we can calculate from this amount and the molar mass. So molar mass is 58.5 and the given mass that I have shown here black. So I'm writing here as well in black so that you can understand that this 58.5 is the given mass and this is the molar mass. So what would be the answer? It is 1 mole. So 1 mole sodium chloride is given in our data. So first you have to calculate the volume. So you need this equation, whether you rewrite the equation here or use from the question paper. We need only sodium chloride and chlorine. We will ignore rest of the components in this equation. So if you observe the balanced chemical equation, it is not balanced. There must be two. So from this balanced chemical equation, it is shown that 2 moles of 2 moles of NaCl produces 1 mole chlorine. So we will start our calculation from there, that 2 mole NaCl produces 1 mole chlorine. So 1 mole NaCl produces 1 upon 2 mole of chlorine, that is 0.5 mole. And we know 1 mole chlorine occupies 22.4 decimeter cube at STP. So how much 0.5 mole chlorine will occupy? Definitely you will multiply this 22.5, 22.4 multiplied by 0.5. So it would be 11.2 decimeter cube. So the volume of chlorine is 11.2 decimeter cube. This is the answer of your first part. In second part, you have to calculate number of molecules. So you know Avogadro's number. You know 1 mole chlorine is equal to 6.02 into 10 raised to power 23 molecules. So you have 0.5 mole. So what are the number of molecules? So multiply this with 0.5, 6.02 into 10 raised to power 23. So your answer is 3.01 into 10 raised to power 23 molecules. So this is your answer. For the second component of this question, you, if you want and you have enough space, then you can write these answers as a result, or otherwise you can leave it as it is. So I'm writing here as a result, volume of chlorine produced at STP is 11.2 decimeter cube, and the number of molecules, number of chlorine molecules are 3.01 into 10 raised to power 23.